All right, let's add another vector. Velocity. What is velocity? So velocity is a change in position over time. So I will actually just pause right there. A change in position is displacement, but now it's a change in position over time. This means we're talking about a rate. So another way of thinking of this is the rate of change of displacement, or I should say the rate of displacement. In equation form, we're going to use v for velocity, and we will have horizontal velocity and vertical velocity. So the horizontal velocity will be v sub x, and that will be equal to the change in position, change in horizontal position, over the change in time. We can also talk about vertical velocity, v sub y, and that would be the change in vertical position over the change in time. Horizontal and vertical velocity, different directions. So for example, a velocity might sound like 8 meters per second to the right. So it's got the rate, right? Meters per second and the direction. Or something like 37 centimeters per second upward. Or something like negative 4.6 meters per second, which just means it's moving in the negative direction. A positive value for velocity means that the object is moving in the positive direction. And a negative value for velocity means that the object is moving in the negative direction. So let's take a look at some examples. Letter G. What is the car's velocity between its first two positions? So now we're talking about its velocity from this position to that position. So it started at a position of 16 meters at 0 seconds, and then 1 second later, it goes to a position of 9 meters. So what is its rate of displacement? How far is it moving in 1 second? So here we go. This is a horizontal velocity, and it's the change in position over the change in time. Well, the change in position is it's going from 9 meters finally to 16 meters initially, and it's doing that in 1 second. So 9 minus 16, we've got negative 7 meters per second. And that makes sense, right? Because the car moved 7 meters to the left, and it took 1 second to do it. Similarly, what is the letter H? What's the car's velocity between its last two positions? So its last two positions are here and here. So now it's going just 1 meter to the left, and it's only taking 1 second to do that. So its velocity is going to be the final position of 0 meters, the initial position of 1 meter, and it's doing that in 1 second. So negative 1 meter per second. We're going to add our final vector, which is the most confusing, the acceleration vector. So most people, when they think of acceleration, they think of an object that's changing its speed, which is true. But since acceleration is a vector and it has direction, you can also be accelerating if you're only changing your direction. So you could be going at constant speed in a circle, like if you're running around a track. And as long as your direction is changing, you would be accelerating. So here's the definition: a change in velocity over time. In other words, the rate of change of velocity. In equation form, we're going to use the variable a for acceleration, right? We'll have horizontal acceleration. So that would be the change in velocity in the x direction over time. Or we can have vertical acceleration, something accelerating up and down. That would be the change in the vertical velocity over time. Accelerations sound like this: negative 9.8 meters per second, right? It's the change in velocity over the change in time. So the time shows up twice, meters per second. Or you would see something like 4.2 kilometers per hour per second. Or something like 1.6 meters per second. And then instead of saying meters per second, I can also write it as meters per second squared. And then I would want to include my direction. So again, 1.6 meters per second squared means 1.6 meters per second. That means every second, the velocity changes by 1.6 meters per second. A positive acceleration means that the object is being pushed in the positive direction. Being pushed in the positive direction. And here's the tricky part, but not necessarily moving in that direction. A negative value means that the object is being pushed in the negative direction. And I'm just going to change my ink because it's getting a little crowded here. But not necessarily moving in that direction. What do I mean by that? So if something is being pushed in the positive direction but not necessarily moving in that direction, this would be like this. Let's say you have a little toy car on a table, and let's say that you have pushed the car and you have released it, and so the car is kind of drifting on its own. It's cruising. You've released the car. You pushed it to the left. But now you've let go, and so the car is coasting, right? Coasting. You're no longer pushing it. Well, if this table is a little bit bumpy, the car is eventually going to slow down, right? The car won't go on forever because of friction. So at this particular moment in time, while the car is coasting, you've released it, you are no longer pushing it to the left, but friction would be pushing the car to the right, eventually bringing the car to a stop somewhere over here, right? So in this case, we would say that the car is being pushed in the positive direction by friction. It's being pushed in the positive direction by friction, but it's actually moving in the negative direction. So this is moving left I'm going to say moving leftward, but accelerating rightward. Moving leftward, so velocity is this way, to the left. But it's accelerating rightward. Acceleration is in the other direction. Moving leftward, accelerating rightward, because friction is pushing it to the right. All right, here's my final notes. If velocity and acceleration are in the same direction, let me just clean this up a little bit. If velocity and acceleration are in the same direction, the object will speed up. If they are in opposite directions, the object will slow down. And I just gave you an example of when velocity and acceleration are in opposite directions. Car was coasting to the left, so velocity was to the left, but friction was pushing the car to the right, and as a result, it slowed down. So if velocity and acceleration are in the same direction, the object is going to speed up. That's what happens when you step on the gas pedal of your car. Your velocity and your acceleration are in the same direction. But as soon as you hit the brakes, you start accelerating backwards. You're being pushed backwards by friction with your brakes, and so you slow down. Let's take a look at how to identify the direction of acceleration at the end of example 1. And I just realized that I skipped letter I. So let's do that. Letter I, the car's average velocity during the whole trip. So let's try this. I'm going to call this V total, or excuse me, V average. Average velocity in the whole trip is going to be the delta x total, right? The total displacement divided by the total time. So during the whole trip, the car ends at a position of 0 meters, and it begins at a position of 16 meters. And what's the total time that this takes? Well, it's a 4-second journey, right? 4 seconds at the end, 0 seconds at the beginning. So we're going to have negative 16 on top, 4 seconds on the bottom, so this is going to be negative 4 meters per second is the average velocity. So the car went from 7 between the first two dots to negative 1 between the last two dots. And but the whole trip, it was going negative 4 meters per second. All right, letter J. So what is the direction of the car's acceleration? In this case, the car is moving left. So we can say the velocity is leftward, but it's slowing down. Maybe the car is hitting some friction because it's on a bumpy ground, or maybe the car is hitting its brakes, but we can tell that those dots are getting closer and closer to each other. So as it moves leftward, it slows down, right? The distance between those dots is not constant. So if it's moving leftward but it's slowing down, it must be because something is pushing it to the right, which is causing it to slow down. So the direction of the car's acceleration is rightward. Must be accelerating to the right. Otherwise, it wouldn't be slowing down.